So you could say the Earth is flat, right? The problem is, though, that there's an interesting thing. They make a very interesting argument. They say they think that gravity that we feel is because the Earth is a flat Earth is accelerating through the universe. Now that's actually right. Right, as I said, Einstein's theory is that what we're feeling now, we're being pressed into our chairs because the ground is accelerating. The Earth isn't flat, though. Space and time are curved, and it's quite a feat of imagination that you need to do some general relativity to work out how can it all be accelerating and yet the Earth stays spherical. And how can it all be accelerating and yet the Earth stays spherical? And it's one of the things you have to understand general relativity. The thing is that bit's right. So they're right. It's called the equivalence principle. They're bang on.
Well, I mean, do you feel weightless? No. So you are not an inertial observer. Your situation is exactly the same as someone accelerating on a rocket ship in deep space. And let me be clear, I don't mean that being at rest in a gravitational field is like accelerating in a rocket. I mean it is the exact same thing. You are accelerating and there is no gravitational field. Gravitational fields do not exist. Gravitational fields do not exist.
Einstein realized that rather than gravity being a force acting at a distance that accelerates freely moving objects downward, we have to say that instead, gravity puts us in a non-inertial accelerated reference frame. And we have to say that the surface is what's being accelerated upward. So, when you were sitting in a chair, you were quite literally being accelerated upward. Quite literally being accelerated upward. Similarly, when we're standing on the Earth, the ground is pushing us up with a real force. And if that force is removed, our body goes from being accelerated to moving inertially. And then in that now inertial reference frame, we see the Earth accelerating upwards. Any deviation from inertial motion is a real acceleration. And real acceleration requires a real force. Real acceleration requires a real force. When you step on a scale, you aren't directly measuring your mass. You're measuring the force.
It's taught us that gravity is not a force. And that's probably the most misunderstood physics fact ever. Like, even physicists get it wrong all the time. Gravity is not a force. And since there's no force pushing down on you, that means you're currently accelerating upwards. An accelerometer is a device that measures acceleration. If you'd hold an accelerometer steadily in your hand, it'd tell you it's accelerated upwards. This isn't hypothetical, weird, theoretical physics talk. You can buy one and just see what it says. This is an example of how the reading of an accelerometer looks like when it's lying still on a table. It tells you it's accelerated upwards. And this is entirely correct.
Today we say that when something falls and accelerates, no force is making it do that. Even more counterintuitive, the acceleration of gravity is actually upward. It's not downward.
In Newtonian physics, gravitational attraction and gravity are one and the same thing. Masses are the source of a gravitational force, gravity, which thereby causes gravitational attraction. In general relativity, however, gravitational attraction is only an apparent phenomenon. It's fake.
In standard Newtonian physics, we draw your weight force, the force of gravity pushing you down, and the normal force from the floor pushing you up. We say these forces are equal and opposite, so there's no net force on you, so you are not accelerating. But in general relativity, gravity is not a force. You have no weight, so the only force on you are these normal forces pushing you up. So you are accelerating upwards.
If you hold an accelerometer still on the surface of Earth, it's indeed accelerated upward. Why does that surprise you? If you hold something on your hand, you feel that it's pressing against your hand downward. It's like when you're trying to accelerate a car with your hand, it'll push against it. If you hold something in your hand, that's not the gravitational force pushing it down, because gravity isn't a force. It's pushing on your hand because you are accelerating it upward.
It might shock you to learn then, at the surface of the Earth, there is no gravity. None whatsoever. At the surface of the Earth, there is no gravity. None whatsoever. The reason the apple falls to the earth is due to the fact that you, the observer, are accelerating upward. You, the observer, are accelerating upwards through space at 9.8 meters per second squared. Are literally rushing up to meet the apple, as well as towards anything else that might happen to be falling at that moment. And that is the true cause of apparent gravitational attraction. The fact that you're accelerating when you believed yourself to be stationary.
In Einstein's theory, this is called the principle of equivalence. In fact, if according to Newton's law, a person falls down due to gravitational force, then according to Einstein's theory, it's due to the absence of a force that pushed the person up. That is, a person is affected by the force generated by the elevator floor, but it is not gravity. This also implies that we are always in a state of acceleration unless we're in a state of free fall or inertial motion from our point of reference. So then Einstein concluded that gravity and acceleration are one and the same, and therefore we're in a state of free fall until an obstacle appears in our path, which became the basis for understanding that gravity is not a force.
Work out how can it all be accelerating and yet the Earth stays spherical and the same.